All right, welcome back, statisticians. Another way to show our data in a graph is a histogram. So a histogram shows each interval value as a bar. Histograms are an excellent way to not only show discrete values, they are a great way to show continuous values because they cover an interval. My heights on my bars are going to show frequency or relative frequency of each value in that interval. So histograms are great for seeing overall patterns in a very, very large data set. So if we look at this, we got a dot plot. So dot plot and histogram of the duration in minutes of 220 eruptions of the Old Faithful geyser. So we've got a bunch of dot plots, and my histogram shows the same set of data, which, because minutes of a duration, depending on how you're measuring it, they apparently measured to like the nearest tenth, but that could be considered a continuous variable. So you can see this first bar goes from 1.5 minutes to 1.75 minutes, and then from 1.75 to 2, from 2 to 2.25, from 2.25 to 2.5. So you get this nice, roughly symmetric distribution. This is called bimodal because there are two peaks. So there are two modes, and it's roughly symmetric where we have the most data in two different peaks. And it's on the right side and the left side. So it would be roughly symmetric bimodal. So how are we going to make our histogram? We're going to choose equal width intervals that span the data. You need 5 intervals as a minimum. You have to have 5 intervals as a minimum. All right, because if you do less, you don't really get to see what your data looks like. And sometimes if you do more, you might as well do a dot plot. All right. So what they did equal intervals. They did our intervals are 0.25, and then you can see it's the frequency, it's the number of eruptions of Old Faithful, not the relative frequency. So make a table that shows the frequency, the count, or the relative frequency of our individuals. Put values that fall in an interval boundary in the interval containing the larger values. What we're trying to say is my histogram includes the data on the left. So 2.0 is in this bar right here. 2.0 is in this interval, not this interval. You include the left, but not the right. So 1.5 seconds is in this interval, 1.75 is in the second interval. That's what that box is trying to say. This means do not include right boundary as our number. I'm going to have to go back to my non-fancy pen. Place equally spaced tick marks on our smallest value. We've already got that. And draw our bars. So go through and read that if you really, you know what, don't get lazy, Gilbertson, come on. So scale our axis. Equally spaced tick marks. The smallest value in each interval along the horizontal axis. The vertical axis, we always start at 0, so I can see, I don't want those gaps, so I don't mislead people with what I'm showing them. Again, equally spaced tick marks. And we want to exceed the largest frequency or relative frequency. Draw our bars. Make the bars equal in width and leave no gaps. Our bars will be equal width, no gaps. Be sure that the height of each bar corresponds to the frequency or relative frequency. I think that makes sense. An interval with no data value appears as it. So if you have no data, that will be a bar of height 0 on the graph. Okay? So let's look at our sales tax rate problem. Problem, sales tax vary widely across the United States. 4 states charge no sales tax or local sales tax. Delaware, Montana, New Hampshire, and Oregon. Those 4 states do not charge sales tax. So when something costs $2.99, it's really $2.99. So the table shows data on the average total tax rate for each of the remaining 46 states and the District of Columbia. So right here, what they did is they labeled our states. They gave us all the states plus the District of Columbia, and they told us the tax rate. They put the states in alphabetical order, and then they did the District of Columbia last. So our job is to organize this data. Let's make a frequency histogram to display the data. So what we said is, let's break it up. We went from put our intervals of 1. So we said 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. We decided let's take our data, and a good way to count this would be by 1%, which I don't disagree with. 1 to 2 happens once. There's nobody who had no state had 2 to 3 or 3 to 4%. 4 to 5% happened once. 5 to 6% happened 6 times, and they finished up that frequency list. Then they drew in their bars. Well, first they did let's back that up. They drew in the tax rate. They labeled it tax rate as a percent on my horizontal axis. And then they went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then they said number of states, so I know I'm doing a frequency, not a relative frequency, and they put in the appropriate height bars. Notice the most we did was 15, but we counted up to 16, and we counted by 2s all the way up. So what percent of our values in the distribution are less than 6%? Interpret these results in context. So less than 6% would be all of these. Less than 6% would be all of those numbers, or all of these numbers from our table, because sometimes using the table is just easier. So what I'm going to do is I'm going to add all of these up. 6 plus 1 plus 1, that's 8, and divide it by the total number, which is 47. So 8 states or districts charge less than 6%. We did 46 states and the District of Columbia, which gives me 0.170, which is 17.0%. Now, interpret the results in context. 17% of states and the District of Columbia have tax rates that are less than 6%. Now, you can make a histogram on your calculator by doing these steps. Hit your menu, go into your stats menu, put your data into your lists. Enter all those data in. I can hit F1 for graph, set up which graph I want to do my histogram, tell it a histogram, select the list containing the data set, select the graph number using your soft keys, change your starting X value and the widths of the bars, and then you hit your graph key. So if you try that on your calculator, it's going to make a lot more sense. Alrighty, let's complete questions 12 through 18 on assignment 1.2. And I will see you when I see you, statisticians.